Hello and welcome to another Zodian session. How about that? I bet you didn't expect that shit to happen. So today we are continue working on wank tiles. I hope my chat is aligned properly. And we already have an old piece of code for wank tiles that is written in Pascal. Right, and one thing I want you to do today is to try to modernize this piece of code by rewriting it in a more modern language like C. Right, as you can see, if we open it, it is written in Pascal, right? Which was good for 1970s, right? It was okay for 1970s, but in 2021 you need to use something modern, and that's precisely what we're gonna do today. We're gonna try to rewrite this old piece of Pascal code in C to make it more modern and to go and to make it go brrr, if you know what I'm talking about, right? So let's go. Code written by Tolling in the 1970s, yes. That's my 1970s code. Right. I didn't exist back then, but I already wrote some code. Okay. So, wank tiles. And do I need to fetch the latest changes? I think... there we go. Has time travel. Maybe. Who knows? Who knows? Who knows? It's a little bit hot today, don't you guys think? I think it's a little bit hot in here. What's the weather today? Weather Novosibirsk. And the bot is dead. I mean, it got disconnected from Twitch probably. Humid here as well. I'm gonna actually check that on our Discord server, because usually on the Discord server the bot does not disconnect. So let me take a look. It's gonna be weather Novosibirsk. It's the same bot, by the way. It's just like, oh, it's dead on both of the... Okay, that's really weird. Okay, I'll keep that in mind. So it's actually dead. It's written in Haskell, by the way. So yeah, just no. I just didn't put enough, you know, strict evaluations in there. that's why it died. Right. It has 0 runtime errors because it never runs. So let's continue. Wank tiles, and we have 2 modules in here, by the way. We have 2 modules. The first one for linear algebra, for different vectors and stuff like that. So here we have like a very generalized way to work with vectors. Unfortunately, in C is too modern for this kind of generalization. We'll have to copy paste like implementations for 2D vectors and 3D vectors, and we do need 3D vectors because we are working with the colors in 3D space for RGB. And there's also a weird implication here that we're gonna have a 4th one, but I'm not 100% sure. So maybe we're gonna have implementations for 2D, 3D, and 4D, just to be able to represent also the RGBA colors and stuff like that. The bot woke up. Oh, okay. So did it actually woke up? So it's plus. Oh yeah. Okay. So I had a warning from our Ministry of Emergency saying that today, I think in the future, in the next several days, there will be a high, very high temperature above 30 Celsius. So yeah, they just basically send out the SMS notifications for different stuff like that. Usually when it's too cold at winter to be like to be careful, or it's too hot during the summer and we're also surrounded by forest, by the way. We're also surrounded by forest, so it could be actually kind of dangerous in here if it's too hot or too dry. But it's usually like specifically in the place where I live, it's rarely too dry. It's a very humid place, so we don't really have that much of a fire hazard, I would say. But sometimes it happens. Yeah. Today in the future, yes. As I already mentioned, I time traveled. It's 45 degrees C here in India. Isn't India a big country? I think it's a pretty big country, so I suppose it might depend on where exactly in India, right? Maybe in different parts of India it could be different. By wiring is a fire hazard, yeah. Anyway, so let's actually start rewriting things. So I'm gonna create LAC, right, and we're gonna define like a vector, right. India is not as big as the country of Siberia. Interestingly enough, the Siberia, like the area of Siberia could be bigger than the area of India. Because the Siberian Federal District, is that how we call it in English? I don't know. I think the Siberia Federal District, Siberia. If you look it up, but the modern, like the maps, they're actually pretty, you know, warped. So it's kind of difficult to understand their, you know, their actual area. But the one thing you have to keep in mind, the Siberia itself, I think it has a shape of a, well, it has two things in here and these long things in the middle. So usually this is what we call Siberia. So, and it's a pretty big area if you think about it. It's yep. So if you Google Siberia on a map, Siberia on the map, yep, that's Siberia. That's literally Siberia. Yeah, it's a Siberian Federal District. Yeah, that's what it's called. So this is how Siberia Federal. And there's a little bit of islands at the tip of the Siberia, which makes it okay. Anyway, so let's continue rewriting Pascal and C. All right. So what we're gonna have in here? So this is actually going to be the float vector, right? It's going to be a float vector. So, and I want to actually store the components of the vector in an array, right? So how are we going to call those things? We're going to call them C, I suppose, right? So for the component, right? C stands for the component. And we're going to have several of these things. So there's going to be a three-dimensional one, which is 3, and four-dimensional one, which is 4. And four-dimensional is going to be used for RGBA, right? So this is actually pretty small. Maybe I'm gonna actually compress them like this in a single line, if you know what I'm talking about. So look at that, legitness. There we go. So we have 3 implementations of different vectors. So, and we want to be able to access them differently. For instance, I want to be able to access them through X, Y, and Z. Right, X, this is gonna be Y, and Z, 2, and W, in case we're gonna do some, you know, four-dimensional math. I forgot how it's called, but whatever. So we're also gonna have UV coordinates, right? So this one is gonna be U and V. And for things like RGBA, we're going to have the other things, RGBA. So, and the way you work with this kind of shit, right? So basically you have a RGBA caller, right? And you then do RGBA C, R, right? G, B. So it's sort of like, it acts like a union, but it's not really a union, right? So basically you say, abandon the unions, embrace arrays. That's what we're saying. Right. So because it just makes generally things easier, in my opinion. I don't know. What do you guys think? What do you guys think? I think it does make it a little bit easier. Right, because one of the important things I want to be able to do with the vectors is not only to access their corresponding components, but also iterate over corresponding components, right? Especially if you want to find the length of the vector, it's just easier to for loop the components and just sum them up and stuff like that. And, right. And for looping is actually not that, you know, expensive, because the modern compiler will unroll your loop anyway and optimize everything away. So, I wonder if Google programmers are allowed to use unions in their code. Probably not, because they're probably not programming in pure C, they're probably programming in C++. And a lot of things in C with unions that are okay are undefined behavior in C++, specifically into reinterpretation, right? So, which is kind of annoying that it is undefined behavior in C++, but in C it's perfectly fine. It's actually a very useful tool. All right. So let's implement a couple of constructors. So we're going to have a vector 2f, which accepts essentially x and y, right, and returns a vector 2f. And in here, we're going to be doing something like vector 2f. Right, it's going to be, maybe I'm going to just do something like this. V, C, x, x, v, c, y, y, and then we're going to return v in here. So this is a constructor for like a single thing, but I also like to have a constructor for the scalars, right? So where I can provide a single scalar, and that basically automatically, you know, expands this entire thing into the whole vector, right? I like to have these kind of things. I think they're pretty neat. I wonder if I can do things like x and y, right, and just return it like that. I think I should be able to. So, let me see. So this is going to be that thing. My neighbors are doing some weird noises, which is kind of weird. Can you hear my neighbors, by the way, chat? Is it possible to do swizzle like in GLSL? Swizzle is like when you have a vec4, right, of some sort, and you say XYZ. Is that what it's called, swizzle? I'm not really sure if I understand what is swizzle. GLSL. Is that what it is? They have a name for that? I didn't know that they had a name for that. Oh, you can even make it more complicated than this. This is actually pretty cool. You can ask if the components of vector have been following syntax, but it's more of a syntactical thing, right? So semantically, I don't know, but it's actually a pretty neat syntactical thing. I'll give you that. So what's the other operations we need? We need all of the common operations like add, sum, sub, mul, div, and so on and so forth, right? So let's go ahead and do that. So vec2f sum, and it's going to accept vec2fa, vec2fb, right? And what we're gonna do in here is effectively, yeah, so we can do vec2fc, and in here I'm gonna iterate size t 0 to 2 plus I, and c a c I plus a c, actually bci, right? Bci, there we go. So, and then we're just returning the c, right? So it's like that. Something like that. I wonder if I can even make it like this, so it's a single line, and then it will make it easier to copy paste this code later, because as we extend this entire thing to more dimensions, it will be super easy for me to just query replace 2, 3, boom, we have support for 3-dimensional vectors. You see what I'm talking about? It's actually pretty cool, isn't it? Right, so the actually reusable code, as I said recently on my Twitter, the truly reusable code is the one that you can copy paste, right? So I just copy pasted the code, query replaced 2 to 3, and there we go. I have implementation for 3-dimensional vectors. It's that easy, right? So yeah, but we're gonna implement that a little bit later. Okay. So yesu kawaii freaking desu. So this is just a sum, right? So then we're gonna have a sub, and the only difference is gonna be just replacing this with that, right? So yeah, see, easy. Next one is gonna be multiplication, right? Easy. You see, like once you abandon all of these social norms and allow yourself to copy paste code, implementing things becomes super easy. You know what I'm talking about? I think it's actually pretty cool. It's actually pretty cool how easy you can now implement things and whatnot. It's just like you abandon all of these stupid social norms. Just copy paste. Come on. Just copy paste. Relax and copy paste. All right. So what we're gonna have in here, is that enough? So as far as I know, in the original module we also had some other things. So we have a scalar constructor, plus minus multiplication, we don't need that. We also need the max, I think, right? So let's quickly go ahead and implement the max. So it's going to be vector 2f. Vector 2f max is going to accept, might as well actually, maybe copy paste this thing as well and say max. Right, and the question is, how are we going to approach the max? In case of a max, I suppose we're going to do the following thing, right? We're going to have the following logic, right? If ACI is less than BCI, we are assigning ACI to BCI, right? And after that, we're straight up returning A. You know, so essentially, since we're copying A by a value, we're also using A as a return variable, right? We're also using A as a return variable, which actually brings me to a very interesting conclusion. Can we do the same like everywhere? Right, so just don't allocate anything on the stack and just do something like A plus equals and just return A. Right, because these two variables are already on the stack, right? So you don't need to allocate any other variables. You know what I'm talking about, chat? You know what I'm talking about? I think it's actually pretty cool. I really like this idea. So yeah, you don't have to do that. So the whole implementation becomes simpler, I think, right? So just the whole thing. So here we have subtraction, and yeah, that's pretty cool. I like that. So this simpler implementation, the less the probability that you will make some sort of a weird bug, if you know what I'm talking about, right? So yeah, if you want to avoid bugs and some other stuff, you just make things simpler. That's how you do that, right? You just make things simpler. Okay, so that's pretty cool. Can I also make this thing like a one line? Right, so it's also one-liner. So if it's a max and A is less than B, so we are assigning B to A, and then we return A. So here's the max. And for the minimum, right, for the minimum, we're going to do pretty much the same thing, but the opposite, right? So it's just like the other way around. Yep. I wonder if there is a way to do that without the branching, but maybe the compiler is capable of optimizing this and getting rid of the branching. I don't know. I'm not as low level, you know, developer as Casey, for instance. Casey would probably use some sort of like SSE instructions or something like that to actually make it super fucking fast. But I'm just a dummy. I'm just a dummy, thick. Not really thick anymore, unfortunately. But anyway, so we also need length, right? So we also need length. So vector_f len vector_f a. So in here we'll need to have some sort of accumulator, right? So it's going to be something like len, and initially it's going to be 0. So we are yet again iterating the entire thing, right? Here we go, and I do len plus it's actually square len, right? It's a SQR len, I would say, right? So here's the SQR len, and I do ACI, right? And then I return SQRTF of SQR len. There we go. It's quite often maybe when you're just checking if something is closer to something, you probably don't need square root of this entire thing. Maybe we could have like a version that is literally like square length, right? Which is just that, and it just returns you a square length. Even if you need the proper length, you would just square root that specific length, if you know what I'm talking about. Right, and I don't like this underscore. I think this underscore is not really great. Yeah. So vector2f sqrlen. So basically that fits into more situations, right? Because quite often maybe you want to just check if something is close enough to the square of the radius, but if you need an actual length, you just sqrtf on top of that, right? So it's just like fits into more use cases, if you know what I'm talking about, chat. Right? Make sense? Hopefully. So we also need lerp, right? We also want to be able to lerp the vectors accordingly. But here's the thing, we need to have a lerp that works with a single component, right? So somehow. So let's actually quickly implement such lerp. Because I'm pretty sure C doesn't have a lerp, right? C++ does. Okay, yeah, C++ does have a lerp, but C doesn't. Wait a second. Well, I mean, isn't that lerp? It's a C math. Lerp. Was it a clamp or was it a lerp? I don't remember. MSVC implementation. Yeah. Oh, okay. But it was MSVC. We're not using MSVC. Yeah. So yeah, I do remember this one. This is the I keep bringing it up because it's so hilarious. So yeah, probably if you watch me quite often, you probably know this thing, right? So let's actually put it like this: beautiful lerp implementation. Implementation by MSVC. There we go, and here is the source code. So there we go. So also I'm gonna put like a previous episode here as well. There we go. There we go. So we have a float b, float suppose t, right? And the whole implementation is effectively b minus a multiplied by t, right? That's what it is. But maybe we could use something from GCC. So math lerp. I don't see lerp in here though. Maybe I don't even have it. Because which standard is that? So which standard is that? So if I go to C, right? So oh, C doesn't have that apparently. It's a C++ thing, but it's located within C math. That is kind of weird, isn't it? Why is it located in C math if it's not? Okay, that's okay. So math.h. I guess I'm gonna implement my own lerp. So let's just go ahead and implement our own lerp because it's easy enough, right? Anyone can implement their own lerp. I'm gonna say it's lerp, right? Because it works with floats and stuff like that. Right, and then we can implement something like vec2f lerp, vec2f. Otherwise, you need to separate math libraries. It's weird. I lost the context. What do you mean? Two separate math libraries. I mean, for C and C++, right? But you can in C, you could disable just that on a level of a header or something. I don't know. It is kind of weird. It is kind of weird. vec2f, vec2f b, vec2f t, right? So, and then we're just doing what? For size t less than 2 plus I. And in here, we're gonna do the usual trick. I, it's gonna be lerp, ICI, BCI, TCI. There we go. So this is how we lerp the entire thing. And then we're gonna just return the A, right? Cool. So that's the lerp. That's the lerp. Let's go into here. So we also have sqrt. Luckily, implementing all these like function-based things are a little bit easier, right? Because you just doing that, right? Sqrtf, and then just do that. There we go. So here is the security. So, and the power, right? So I think power f c power. Yeah, that's the thing. That's the thing we need. So base and exponent. Okay. Base and exponent. Vec2 f, vec2 f, pow, vec2 f. Here's the base. Vec2 f. E, here's the exponent, right? And let's go in here, right, like this. And this is going to be B, pow, E, C, I. There we go. ECI. Alright, so looks good to me. I hope I didn't make any significant mistakes in here. And of course, this thing has to be actually LA nim. And I think I addressed all of the functions that are needed in our mathematical library, right? So, except maybe additional type defs, right? I want to type def vec2f. Maybe something like RGB to vec3f, right? So this is going to be RGB. I think this is how we do that. Yep. So let's try to compile the entire thing and see if it's even compilable. So obviously we'll probably want to include math.h, right? So here's the math.h. This is GCC C, LA.c, and let's go through the compilation errors. Okay, so we've got a sub by the Martin HO23. Thank you so much for 4 months of Twitch Prime subscription. Thank you. And welcome to our Epic C Club. That's right. We're just rewriting the old, Pascal code. Let me show you the Pascal code. This old Pascal code in C, trying to modernize that code. Right, trying to make it better and faster. So yeah, that's precisely what we're doing right now. Thank you so much for the sub. Really appreciate it. So size T, I suppose I will need to include the std lib in here. Right, there we go. Seems good to me. Security len. This thing has to return a float. Cool. And vec2f conflicting types for lerp. Oh yeah, this one is supposed to be sqrt. Okay. And this is vec2f, and there we go. So we managed to compile the whole thing. So there we go. This is the implementation of all of the operations for 2-dimensional vectors, but we actually have more different vectors in here. So we need to have implementation for 3 dimensions, and we need to have implementations for 4 dimensions. Right, again, the most reusable code is the one that you can copy paste, right? So is the one that you can simply copy paste. And what we're gonna do in here, we're gonna straight up copy paste this entire thing. So, and I tried to design this entire thing that the only thing you would require to do is just to query replace 2 to 3, but there's a couple of things that you'll have to do here anyway, right? Specifically for here, if you just query replace 2 to 3, that won't be enough. Right, that won't be enough because, well, I mean, I also forgot to copy paste this thing. Okay, so this is going to be this. Because you need to add additional thing in here, right? Makes sense. And in here, if you try to do something like this, right, you will have to have the z coordinates, right? So this is going to be the z, and there we go. Apart from that, that is it. So what you can do now, you can just query replace 2 to 3, and there we go, you have implementation for 3-dimensional vectors. So yep. Should you really use loop for 2it instead of double affectation? Seems less simple to me. If redundant, then you could write private helper with to abstract instead of copy-paste loops. Probably. I'm not really that familiar with C, so you seem to be more familiar with such languages with C, but I'm only learning, okay? So I'm only learning. If I will have any problems because of the things you mentioned, I'll at least learn something, right? At least my program will fail or it will run slow, and we'll go into that and we maybe learn something, right? Make sense? Make sense? Hopefully. So this is more about like it's a learning experience, right? It's more of a learning experience. We don't have anything running yet, but let's just have something running and then we'll see if it's bad or good or something or acceptable or something like that. Hello, Shodran, welcome to the stream. I just have a question. Can we do some polymorphism in C structs? Depends on what you mean by polymorphism. Could you give a definition of polymorphism? So, what do you mean by that? So, because polymorphism, like it, depending on the context, it may mean different things, I suppose. Because usually use the same code for different structs. The same code for different structs. Even in C++, polymorphism not necessarily means that. Actually, I think. In C++, you could like have a base class, right? And then you have a child 1, which is like derives from that. And then a child 2, and then you have some sort of like a virtual method f. But inside you usually override this thing, right? And you see, you have implementation 1, right? And then you have implementation 2, right? So you have two different structs, and you use different code for different structs, right? If that's what you want is a dynamic dispatching based on the type of the struct, well, you usually do it the following way, right? So you have two structures, right? So like foo, right, foo and bar, right? You have foo and bar. And maybe you have some sort of a union. Usually I like to call such union as, right? So here you have foo, and then here you have bar, right? There we go. So you have as, and then you have some sort of like a parent class, which has an enumeration, right? Not really enumeration, but maybe some sort of an indication, you know, what type of the parent it is. Maybe some sort of like parent type. Right, and this is going to be a parent type, right, and then you have a parent foo, and this is going to be bar, and of course this is something like this, right, and then you have something like as, right. So, and then as you iterate through the parents, right, you check the parent type. Maybe switch case even on that parent type, right? And if it's parent foo, you take your parent and reinterpret it as foo, and then you do something with that thing, right? If it's bar, you do it like that. So essentially, you basically store the information about the type within the structure, and you dispatch. Dynamically dispatch to different code based on that, right? Or maybe you can even do precisely what the C++ does, because in case of C++ it has a virtual method table, right? So, and depending on the type, it just like looks up this table and calls the corresponding method. Maybe you can have an array of functions, pointers to functions, and you can emulate this thing in a similar way, right? So where you would literally use parent type as the index in a virtual table of some sort, right? And you would call to that thing, right? And the method in that virtual table will always interpret that parent as a particular thing in there, right? So yeah, the C++ by itself, by the way, doesn't even do anything magical, right? So does it make sense? Do you finish any project you start? Of course, I've finished a lot of projects actually. All right, so here we have a three-dimensional implementation, right? So, and it seems to be compiled. So, yeah, let's actually have now four-dimensional implementation. So here's the four-dimensional implementation, and again for the four-dimensional implementation we're gonna just query replace 3 to 4, and I think it should be relative. Oh, it still compiles unfortunately because C is not being very strict about this kind of stuff. Yeah, so for the four-dimensional one you would have to have something like this, right? And in here, well, that will already fail and it will prompt you to add this thing in here. There we go. So now we have implementation, the same implementation for two-dimensional vectors, three-dimensional vectors, and four-dimensional vectors. Right, so, and yeah, that's pretty convenient, isn't it? I think it's pretty convenient. So we can even have different aliases in here, RGBA, maybe even type def something like 2f uv or something, right? And yep, so we already ported the linear algebra module, right? So here is the linear algebra module, and we ported it from Pascal to C. Cool. So now we need to port the main code, right? So we need to port the main code. So what do we have in here? We have a lot of different things. Primarily they generate the tile set. So the first thing I'm going to do, I'm probably going to just move this stuff to C. Okay, so let's actually do main.c, right? And let's include stdio. And also the linear algebra module. Right, there we go. Linear algebra module. Cool. So I'm gonna literally copy-paste this code here and start porting it. This is actually a pretty interesting way to port things, right? Just copy-paste the code from one language, right, and just adapt it to another one and make sure it compiles. I think that's a pretty cool idea. Right, so, and I can now try to basically compile these things. Oh, main. And, oh yeah, and you have to link it with the mathematical libraries. Right, so there we go. As you can see, we already ported 4 lines of code from a different module, and it seems to be working fine. Seems to be working fine. Okay, so the next one is stripes, and basically this is some sort of like a shader-like function that accepts UV coordinates, right? It accepts UV coordinates and returns RGB, right? And what it does, it just uses like mathematical sine cosine magic to produce like really weird stripes, right? So let's actually try to port this code to C. So here we have a function that returns RGBA, it's called stripes, and it accepts UV coordinates, right? So, and in here we have a parameter called n, right, which is 20 for some reason. And what we're returning here is a three-dimensional vector where the first component is this thing. All right, so the second component is this thing. Right, and the third component is this thing. Right, there we go. So, and this is not going to properly work because we have to prefix it with f, meaning that this is a sign that works with floats. Also, I want to mark all these literals to be floats because by default these literals are doubles, right? So we have to be a little bit careful with all of that. And on top of that, we'll have to put this like this because you have to directly access the components of the vectors and so on and so forth. Oh man, okay, so looks-okeg. Interestingly, so each component, if you take this entire thing, right, if you take this entire thing and you remove these components, like to x, y, z, actually not even like that, but rather x, y, z, you will see that we perform pretty much the same operation on those things, right? So if we took this xyz thingy and put it into a separate vector of some sort, all right, so maybe it could be called, I don't know, vec3f, and I'm gonna call it V, right? So I'm gonna grab this thing, I'm gonna grab this thing, so this is gonna be the first thing, 3F, and this is gonna be that, right? So this is gonna be that, and this is going to be that. This is going to be that. All right. Okay, so we have this stuff, and now once we have this vector, we can easily just translate it like so: vec2f sum, right? So we're doing sum of v plus vec2fs1, and then we can multiply this entire thing with vec2fs like this. So this is basically what you perform in here. So and then we can just simply return the entire thing. Right. So that's basically what's going on. Does it make sense? Let's see if this entire thing even compiles. It does not compile because oh yeah, it has to be three-dimensional one. There we go. Incompatible type with vec3f. Expected float, but argument 3. Am I being an idiot? Vec3f. Alright, so I need to read the compilation error a little bit more careful. Oh, I see. So there is a... I'm being an idiot right now. So is there something wrong with that stuff? It accepts two vectors in here, so here's the sum. Vec3f, if we take a look at the vec3f, it accepts, okay, so this is a vec3f, this is a vec3f, vec3f sum, oh, okay. Multiply, okay, I forgot to put a multiply in here, right. I see now, okay, that makes sense. Okay, so we ported one piece of code in here. It would be kind of cool to test this piece of code, if you know what I'm talking about. Right, so it would be nice to test it, but to test that piece of code, we need to port the thing that saves image, a particular image to the didn't think. By the way, chat, I recently understood the point of stride or pitch in images. Do you guys know what it is? Like stride, pitch, or whatever. So if I take a look, like image, stride, like different people call it differently, right? So pitch, more of it. So this thing, it's usually called some sort of a padding. And a lot of like graphical systems have this kind of shit, where you have width and height of an image, but it's stored in a bigger buffer where it has a padding at the right. And when you are passing information about your image, you have to pass information at where the pixel starts, then the width of the image, the height of the image, and also some information about the padding. Usually you pass the padding as this length, right? Or you can pass the padding as the full length of the buffer that is that the image is contained with. And I knew about this kind. Oh, so the padding is this thing, and the stride is the whole thing. So there's an image width and there is a image stride, right? The image width and the image stride. I knew about this thing for quite some time. A lot of graphical libraries and graphical systems sort of work this way, where you have an image width and also stride, and I basically accepted it without even trying to understand why the hell they have a stride that is bigger than width, and what's the point of this entire thing. Do you guys know what it's for? Do you guys know what it's for? It only recently clicked in my head, why the fuck do you need that? And this is amazing, actually. And it's such a simple idea. Why the fuck do you need this kind of stride? And it's beautiful. I'm actually surprised it took me so much time to realize that. Alignment or... No, not really. Well, you can probably use it for alignment, but from the programmer's practical point of view, why the hell do you need a stride? Right. From the programming practical, because it has a practical implications, not performance, not anything, but actual practical implications. This is something that you, like on CPU, may want to do to organize your code and workflow better. This is something that you may want to have in your code, not in the code that interfaces with some graphical system that decides that you need a stride. No. You may also use it in your own code when you design things. So this is actually quite beautiful. Let's take a look at it. I'm gonna try to lay out my process of thoughts, right? Right, so you have an image, right? And it looks like this, right? So let's say that it has a first row, and so basically A's are the pixels of the first row. So we're gonna call this row A row, right? So then we're gonna have a B row, it's not B row, and then C row, and so on and so forth. So you have A row, B row, C row, and you know, so on and so forth. And I've been more excited to realize what's the source of my pain when using graphics API. Okay, so you may how this entire image, right? So you have this image, and how is this image stored in memory? Usually, it will be stored row-wise. It's like in video processing, you have blocks like 16 by 16. Compression processing goes there. Yeah, I suppose you can also do that for now. Anyway, so this entire thing is stored in memory linearly because the memory is linear, right? You go from 0 to n, right? And if you have two-dimensional image, you are forced to store it like this. So this is how your image is actually stored. So maybe I'm gonna actually maybe put it like this, right? So this is your image, but this is your image in memory, right? Now, imagine that you have a sprite sheet or an atlas. What is a sprite sheet or an atlas? Sprite sheet atlas, right? So it's basically when you have several images on a big single image, something like this, right? So, and how is it going to look like? Right, so let's actually denote the pixels of the second image in a sprite sheet with numbers. 1, 2, 3, 4, 5, 6, right? And here is the pixels of the second image. So we have two images in here. Right. So, and how is it going to be stored in the memory? How is it going to be stored in the memory? Well, by the same logic, it's going to be stored like that. So, right. So first comes the row of the first image, then comes the row of the second image, then again row of the first image, and so on and so forth. So if you have an image, smaller image within a bigger image, so this becomes the padding that you have to ignore if you only care about this image. Right. But what's interesting is that it applies to the second image as well. For the second image, you have absolutely the same padding. Because again, so here's where the second image starts with, and the padding for that image is going to be the next row of the first image. Then the padding for that row is going to be the previous row of that image, right? And there you go. Here you have a padding. Right. So basically, Stride allows you to store several images in a single sprite sheet and ignore the rest of the images. So basically, it allows you to specify with only three things. The beginning, the pointer to the beginning, uint32 ptr. This is where your image begins. The width of the image, right? Width of the image. the height of the image, and the stride, right? So you have 4 numbers to represent a sub-image within an image. 4 numbers. If you were to take a more naive approach, where you would say, okay, I have a square and I have a sub-square. For the sub-square, you would say, okay, this one is actually even deeper than this, because for the sub-square, you would say, okay, I have 2 numbers, the position and the size. But again, you still need to know the stride to actually find the bits in here, right? So yeah, it's not gonna help you. So basically you can define a sub-image within an image with just pointer, width and height, and stride. But here's another interesting point. Width and height is usually in pixels, right? Width and height is usually in pixels. But stride is usually in bytes. So this has implications as well, and this is very fucking interesting. You can imagine this being used for matrices and stuff if you want to take a submatrix. Yes, 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 it could be also that. But here's another interesting thing. You have different measure units for width and height and for the stride. What's up with that? So pixels may have different sizes and bytes, right? If you have 32-bit color, different number of components, exactly. So if you have 32-bit colors, this is going to be 4 bytes. But what if you want to store several images with different pixel formats within the same atlas? Well, this is why stride in bytes, because it allows you to just skip like lines by bytes. This is so freaking genius, like holy fucking shit. And it took me 10 years to realize the use cases for that. It took me 10 years to understand why the fuck people do it like that. For those people out there saying that I'm smart or something, it took me 10 years to realize that, like I'm that dumb. This is also useful for vertex buffers. Yeah, it's also... And by the way, the thing that helped me to understand this thing is also working with OpenGL more, right? So, yeah. Because you can basically put all of the vertex attributes in a single buffer, and then using strides and offsets, you can specify what sub-buffer corresponds to which vertex, and you don't have to create a separate vertex buffer for each individual vertex attribute. So that's what kind of helped me to understand this entire thing. So, and this is so cool, and I only understood it yesterday, after the yesterday stream, when I was just like having a dinner and so on and so forth, about thinking about different programming concepts. It's just like it just fucking clicked in my head, like, holy fuck, that makes perfect sense. I still don't understand. Don't worry about it. So the things are like, if you don't understand something about like something right away, that means the time has not come, right? Because usually knowledge, it piles on top of your existing knowledge. So if you don't understand something right now, that means you don't have required pieces of knowledge to understand it fully. So just give it some time, right? Just give it some time, do some other things related to programmer, maybe like in a year or in a 2. When you have the necessary pieces, you will remember our conversation, you will remember this explanation, right? And then we'll go, ah, that's what he meant. Okay. So don't worry about not understanding this right now. The fact that you stumble upon this stream and you listen to this explanation already means that you're on the right path, because you already have some pieces of information that will click later in the future. Not right away, but maybe in a year or 2 or 3, or I don't know, in my case in 10. So it depends, I just need to give it some time. Different pixel formats within one sprite sheet does not sound like a common situation. Depends on what you mean by sprite sheet. You mean sprite sheet like a literal PNG file that you put like as an asset thingy? Or by sprite sheet I mean I meant a region of memory that contains several images. So yeah, I did like my understanding of sprite sheet is more generic, more general than a file in a particular format, right? For me, it's just like, you know, a collection of bytes. So yeah. Once you need to view an API that requires you to specify a stride, it will start making sense. Yeah. So it's pretty poke. All right. So you can assign a resource object property in some game IDE. Those can have different formats, I guess. Yeah. But even if it's not a common situation, it does not really invalidate everything I said before. Right? Just remember the full thing I said before. I said a lot of things about strides and, you know, alignment and stuff like that. And you say it's not a common situation to have different formats in a single file. Well, first of all, my understanding of sprite sheet is slightly different than yours. Second of all, it does not invalidate everything I've said before. So, okay, Twitch chat being Twitch chat. Okay, Freefu, what's up? What's up? What's up? All right. So let's make a small break. I really want to make a cup of tea. And after we made a cup of tea, I think we're gonna continue porting things. Specifically, I wanna port the thing that generates the pixels and just, you know, saves it just to see if this particular shader works correctly. Right. All right. So, okay. So this is gonna be something like this, and there we go. Yeah, but I forgot that I'm also recording things. Okay. All right. So let's go ahead and try to apply our newly gained knowledge of strides and shit like that to practice, I suppose. So maybe we want to actually. So we have save a tile set. Yeah, let's implement the following thing. Generate tile, right? So, and in here, we're going to be providing the pointer to the pixels of the tile. So maybe it's going to be tile pixels. Right, then we're going to have a tile width, right, the tile width. Then the tile height. Right, and since I want to be able to generate the tiles within the atlas, right, I think I'm also going to provide the stride, right. I think it's going to be pretty cool. So you can, this will allow you to pre-allocate a huge atlas and then iterate through all of the tiles and say, okay, generate that tile there, 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 and there, right, and knowing the stride, we'll be able to actually do that. I'm not sure if I need to prefix this entire thing with tile, because I'm not planning to pass any other images in here. I think this prefix is kind of redundant, so I'm going to remove this prefix. So, and what we're going to be generating in here, so maybe it's not going to be generating tile, but more of a generate image, right? Right, and what we're gonna pass in there, I think I want to pass this function as a function pointer. So this will be actually pretty pogue. Let's actually define type def, and this is gonna be like a shader. Let's call this thing a shader. Maybe it's gonna be frag shader. And it will accept the UV coordinates, right? So, and I think this is how we do that, and it will return RGB documents, RGB coordinates. And there we go, we accept the shader. So what we're going to be doing in here, we're going to be iterating the width and height, right? The width and height. Oh, we also need to know the size of the pixel. We're going to assume that the sizes of the pixels are going to be 32 bits, right? They're going to be 32 bits. So I'm going to start iterating by rows, right? I'm going to start iterating by rows. And this is going to be something like height plus h. There we go. So, and then we're going to be iterating by columns, right? It's going to be width plus x, right? So now we need to generate the UV coordinates. So the way we do that, we convert x to float and we divide it by the width of the image that we're trying to generate, right? So, and that gives us the u coordinate. Then we need v coordinate, which is y and the height, right? And then we're generating a single pixel in here. So we use the shader, we provide the vec2f uv, and there we go, that gives us the pixel. So, and now we need to store that pixel in the image, right, which is described with pointer to the beginning of the pixel, width and height, and the strides. Right, width and height is the amount of pixel stride. So since all of our images are going to be 32 bits, and I don't plan to use any other formats with different size of the pixels, maybe both, like all of the width, height, and stride will only mean pixels. I think that's going to be a good idea. Right. So, and in here we're going to actually accept 32, like this. So that will make it a little bit easier for us to work with. And of course, this must be a pointer. Right? This must be a pointer. All right, so yeah, I need some sort of a function that can produce RGB32. So, and I think this is the function that we need to port in here. Look at that. This is the function. So we can define another type def, right? So it's going to be RGBA 32, and it's going to be uint32, not unit. So, and I'm gonna actually let's actually let the compiler to complain about this kind of stuff. Okay, so let's port this function specifically. Let's port this function specifically. So what this function does, it accepts R, G. This messes up with my brain. B. RGBA32. There we go. RGBA32. So, and what we need to return in here, essentially, this thing. So it's going to be return, boom, and I don't even need to change OR. Well, I mean, I think in C you can use OR and it will work, but in C you probably have to do something like this. Shift left is going to be like this, right? So this is a shift left, and here we are actually converting. I'm not sure what I want to do with this thing. Do I want to round them up, or do I want to just straight up truncate them? I think I want to straight up truncate them. I think it's going to be fine. All right, so yeah, there we go. I think I ported this thing. Okay, so there we go. So we ported this function. Now for the pixels, right, I'll need to find y multiplied by the stride, that's quite important, plus x, and it's going to be equal to make RGBA. So this is going to be pixel. Let's actually call it p. Oh, it's a component r pcg pcb pcb. PCB. All right, so, and there we go. So we made the thing that generates the image 32 based on the shader. PCB loop. Okay. All right, so let's recompile the entire thing. RGBA 32. Oh, you need to put semicolons in here, of course. RGBA to unknown type, so we have to include stdint.h and okay, so you have to do that in the other way. I keep forgetting how to use C. I'm only learning C, okay? So this one, yeah, so this is not how you cast things to other things. That's right, that's how you cast them, I think. Yep. Okay, it seems to be working. It seems to be twerking. How about that? How about that? Seems to be working, seems to be twerking. So now we can generate an image. anything I want to do. Let's allocate some memory for a tile, right? So let's say that we're going to have RGB32 tile, and this is going to be tile width multiplied by tile height. There we go. So we have this thing. And then I want to generate image 32. I'm going to provide the tile. Width is going to be that. Height is going to be that. And width is going to be that. There we go. And the shader is going to be stripes, right? So what I'm going to do now, I'm going to go into the debugger and just see if, like in the debugger, in the memory, if it fills up the memory with something at least. So let's actually recompile the entire thing and also add the debug information. Okay, seems good. So I'm gonna do GDB, GDB, so does it produce, okay, it was main. This is not a, okay, I'm sorry. I panicked a little bit and closed my tmux, alright? Alright, so this is gonna be GDB, main, break main, and let's just run the entire thing to enable, and if we take a look at the tile, it's a huge array. I think we can even take a look at first like 10 elements in there. Requires bytes, which is more than... That's really strange. Okay, so I can take a look at the first 10 elements. Then I step, it didn't crash, and if I take a look, it's supposed like it has once. What if I load more things? Once repeated 100. Okay, so it's just once. That doesn't look right, if you know what I'm talking about. That definitely doesn't look right. It's simply once. Should be more than that. But maybe I just misunderstanding something. So the size of the tile is actually quite small. So if I take a look at 124 by 124, I wonder if I can do that with this kind of stuff. Yeah, so it completely filled with ones. So there's something sus going on, if you know what I'm talking about. It is a little bit sus. It's tiny bit sus. Okay, so let's actually try to rerun the entire thing. I'm gonna break main, and we're gonna run the entire thing, and we're gonna step into that. So if I take a look at the width and height, right, width and height, and the stride, so everything seems to be okay. Okay, so X, Y, all right, U, V, all of that makes sense. If I go into the shader, okay. Should have actually went into the shader, but I mean, yeah. So in the pixel, oh shit, okay, I missed it. So if I print this thing, all right, that looks more or less right. That's what I would expect maybe from some of these things. That looks all right. So, and if I step into that stuff, so yeah, we do have R, G, and B, and so on and so forth. You know what? I think I know what is going on. I think it's just C being C again. If that's what I think it is, I'm gonna be super mad. Oh, there's also this thing. Oh my god, C is just like... Maybe I need to enable more warnings. Okay, if I put this thing, will it catch this? No, it doesn't even catch that. Okay, cool, thank you very much. Alright, so if I do GDB, break on main, run, and let's take a look. So if I print the tile, then I print the tile again. Now it looks more or less like some... Yeah, okay, so now we have like different data in here. Yeah, so, okay, so this looks like pixels, right? If you take a look at them in hex, here are the pixels of an image. You know what's cool we can do now? Since we're using the C, we can straight up use STB library to save it in PNG, not in some PPM or whatever the fuck it is, right? So let's take a look at STB image, right? Let's just grab that. And we don't even have to worry about that shit. All right, so stb image.h. There we go. Let's download this thing. Let's grab it raw. Gotcha, Hyper. I like my libraries raw, if you know what I'm talking about. Okay, so I'm gonna include stb image, right, and I'm gonna define stb image implementation of our. Okay, so and let me try to compile the entire thing. Okay, it takes a little bit more time to compile, but anyway. So stb image, stbi save. I think. Oh shit! We actually have to use write instead of. Okay. Yeah. Okay. So let's download another one. Instead of image, we actually needed write. Right. We actually needed write. Let's download this thing instead. And okay, main.c. So this one is going to be right, and I suppose it's also right in here. Is it going to work? Is it going to work? Okay, so there's like a couple of warnings. Oh shit! Does it now collide with those things? Fuck! Really? STBI image also rewrites them? Define X? No. Fuck, no, I don't really know why it's complaining about this kind of shit. So, expected identifier, float Y. Oh, fuck. I see what's going on. Well, I guess the easiest way to solve that is to actually include this thing before we included LA. Right, so now there should be, okay, now there's no collision. All right. STBI write PNG. Okay. There we go. So we're gonna provide some sort of like output PNG. Width is gonna be tile width. Height, the amount of components is gonna be 4. The pixels we store this in is tile, but the stride in bytes is quite important. Is the tile width multiplied by size of RGBA 32, right? Which is going to be 4, right? And if this thing didn't succeed, right? Output file path. Output file path. Alright, and it's gonna be something std error. Could not save file s. Output file path str error no. We're gonna exit with 1. Alright, does it compile? So we also need to include the string and error null. Okay, so here's the result. So this was generated by our program. I think it was even faster. I think like it's super fast. What the fuck? So if I take a look at 512, so the primary problem with compiling the Pascal program was that the compilation of that Pascal program was slow. So the compilation of C is actually way faster. Right, and we can try to do something like this. So here is the main, and it already produced the final result. So there we go. How slow was it? We can take a look. So right now the Pascal program is not equivalent to what we have in here, right? So I think we can compare the performances when I finish the C version, so they are at least equivalent. and then yeah, then we can compare the performances. This is actually looks pretty cool. It actually looks pretty cool. All right, so let's actually port the rest of the shaders, right? We have several shaders in here. So where was that? Main.nim, right? So the another one that we had was Japan, so let's actually port Japan as well. So this is going to be stripes, this one is going to be Japan. RGB, Japan, UV, UV. Cool. So we had float A and vec2 F S, vec2 F sub UV. Right, and what we need to do in here, we need to take the length of this entire thing. Right, but we only have a square length, right? So, and we can check if it's greater than the radius, and because of that maybe we can put the radius in here, but we need to compare it with the you know, square radius because it's a square length. And after that we need to return vec2 F, actually 3F, excuse me, 1. This one is actually int, right? That means I will have to convert the entire thing to float. There we go. Okay. So we're gonna go ahead and replace this thing. So where is that? Stripes, Japan. Okay, so there we go. So we ported the shader, right? That was generated by the C code. So now we need to port the Wang tile, the Wang tile generator. The Wang tile generator. Main.nim. So proc Wang. So with the proc Wang, we have a pretty interesting situation as well. Right. So we also need to port, well, I mean, copy the to-dos as well, because I think to-dos are pretty important there. So here is that, metables, right. So, and how are we gonna tackle this entire thing? So, yep. This is gonna be RGB Wang uint 8t bltr. Maybe I'm gonna have like a special type def alias for the bltr. BLTR stands for bacon, lettuce, tomato, and radish. It stands for bottom, left, top, and right for the size of the tile, right? So that's what it stands for. So maybe I'm gonna also create something like BLTR. There we go. And this is gonna be type def. BLTR. Cool. So we have a thing called here a radius, right? So here's the radius, and we're gonna have different colors in here as well, I suppose. So here's the RGB colors, and so the first color is gonna be vec3f, like this. Maybe I actually wanna like take the entire thing, right, and just like port correspondingly, right? So it's a one-to-one translation. One-to-one translation RGB, right, something like this. And this is going to be something like that. You might as well also query replace the hashes with this thing. Boom. It's not readable actually. It produces pretty gibberish C, which is understandable because it's not supposed to be read by a human. So I'm gonna put this thing like that. So I think I'm gonna replace it with that. Replace this with that. Boom. And here we're gonna have vec3f. Boom. 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 Cool. So here are the colors. Right. So there's another interesting static assert in here that I would like to actually introduce. Right. The size of colors divided by the size of a single element of this thing has to be equal exactly 2. So that's what we expected here. Right, so it's just like in case if you uncomment more things that you're supposed to have here or less things, right? So the code below expects, you know, the size of this array to be exactly 2. So that's quite important, I think. Colors array must have exactly 2 elements. There we go. So that's what we have. So now we have the sides, right? So this thing is actually sort of like constants, a constant and static. I don't plan to modify it. All right. So this also could be static and const. Sides, we have 4 of these things. And I'm gonna query replace this thing with just that. And Emacs. What the hell are you doing, Emacs? And then we can say vec2f, I think. So we're gonna put it like that. So this is the sides. Now we have the sides. After that, so we have a BLTR. So what's cool about in C is that I don't have to create a separate thing in here, right? Because the BLTR mask itself is modifiable because it's on the stack. So I'm going to be starting iterating the sides, right? So it's going to be size t04 plus I. So and vec2, by the way, this thing has to be vec2f, I think. Vec2f. Vec2f p sides I. Sides I. So then we're gonna have a t, right? Which is 1 minus. So this is the length. And then we divide it by a radius. Here's the question. I know it's a dumb question, but let's put it this way. A divided by equal. I think not. Well, I mean, I think it is, okay, it is equal to AB, right, multiplied by A B, right, that's what it's, okay. So it means you'll have to still take a square root of it. And why do we need that? Why do we need that? Yeah, we'll still have a take a square root of it. Yeah. Sure. So I was just thinking, do I need to take a square root of it? I think I do need to. Okay, so vec2f sub, we're going to be subtracting p from uv, right? And then I'm going to do vec2f sqr len. Well, you know what? Let's actually introduce len. I think it would be nice to have a len, right, instead of sqrt len. Right. So I'm going to go to here, sqr len, right, and we're just going to have a version of simply len, which basically returns sqrtf of vector2f sqr len of a, right, something like that. So it's just going to be a little bit easier. vec2f sqr, actually sqr len. So this is the third one. Right, so it's going to be query place 2, 3, boom. Right, sqr len. So this is the fourth one. Cool. 3, 2, 4. There we go. So we're gonna have this thing. All right. So sub len. Then we divide this by 3 and by r, and we need to find the minimum. We need to clamp this entire thing, right? We need to clamp. Automated code generation, yeah, exactly. So I think in the math library you have fmin_f or something. Yeah, there is fmin_f and fmin_l and so on and so forth. We could probably use that shit. Which actually brings me to a very interesting question. So I could have used those functions here. Fmin, like, yeah. I don't know why I did it with the branching, because maybe fmin_f doesn't even do any branching for this kind of situation, if you know what I'm talking about. Yeah, I think I'm gonna put it to do. So it use fmin_f fmax_f in you know, vec f I don't know, min max operations. All right, so let's continue. So what do we have in here? So this is going to be the length, right? So this is going to be the length, and min f. So this is going to be minimum between 1, right? And there we go. We have t. So then we have to grab the color, right? So this is going to be RGB C colors, BLTR, and we're only going to be, yeah, we're only going to just do one, right? So we're extracting the bit, right? We're extracting the bit. So we also have the result, so it's going to be vec3fs. So initially it's going to be probably 0, so it's all going to be 0. So, and result is going to be basically lerping the result from the result to C with that specific alpha, right? So lerp, we're doing lerp from result to that specific color. Might as well inline it. I don't think doing it like that actually makes sense. And then vec3f s is going to be t. Lerp. And then we're basically taking the BLTR like this. Maybe we can use the binding operator like this. I think it should be possible, but I don't know. I want to do it like that. I feel like doing it like that. Okay, so that performs all of the color mixing. Thank you for flushing me. I really appreciate it. So, and we want to do the gamma correction, right? So we want to take the result and raise it to the power of 1 over 2.2. Right, and we actually discussed the gamma correction at some point. Right, so for more explanation on gamma correction and stuff like that, I probably recommend watching the minutes physics video. Minutes physics video. Minutes physics gamma correction. I think it's just colors, right? So I'm gonna put the link to that video in the description. Watch the previous video, yeah. All right, so you want to watch this one. May I ask why you writing this code? I'm new here. It's a pretty good question. It's for the same reason why mathematicians solve equations, or why philosophers like discuss things, or scientists trying to research something. For the same reason, it's a form of a recreational activity, you know. Does it make sense? It's a form of recreational activity. That's precisely why I'm doing that. Okay. So yeah. On gamma correction in computers. Okay. All right. So, and we need to rise this to a particular power. So it's going to be vec3f power result, vec3fs 1 over 2.2, and we're going to reassign. We're going to just return it, right? So there's no need to, you know, have a separate function for that. I think we ported everything in here. So here is the entire shader that generates the Wang tile. All right, so vec3f and initializer is not constant. God damn! God damn, this is not constant. Okay, but I mean, we can quite easily make it constant. Right. Can we? Yeah, we can just do something like this. And yeah, I guess that's fine. Do we have anything else in here? So it's the same situation, yeah. It's the same situation, All right. So Lerp, this one has to be vec3f Lerp. Lerp, actually we already have f, and it looks like it's working. So Japan, and I'm gonna replace Japan with Wang. Right, and now this thing should well, it doesn't really work properly because Wang. Oh yeah, this one is interesting. I need partial. I need currying. Can anyone implement currying for C, please? I need curry. Fuck. All right. Okay, so we can always curry things manually, I suppose. I suppose we can curry them manually. Currying is my favorite programming concept. Oh yeah, along with the recursion. It's okay, I guess. So let's actually have something like I don't know, 0, 0, 0. I have an idea, actually. What if I do something like bake BLTR, we accept BLTR and the shader. Right, so we accept BLTR and the shader. And okay, this one is actually very interesting. Do we have a binary shite? I don't think so. I don't think we have a binary shite. So this could be a specific value, but you also want to have some sort of a prefix there as well. Right. You want to have some sort of a prefix. Yeah, anyway, so we're gonna have a 0, 0, right? So maybe as we implement it, it's gonna make a little bit more sense. Oh, this is not what I wanted. So this is gonna be just 0 UV, right? And then if I want to have something like 0, 0, 1, I can just have it like this, right? And I just wanted to have a macro that automatically sort of bakes them for me. Right, so, but I think it's too much to ask, at least for now. So this is going to be Wang 0, 0, 0, right. Is it working? Is it working? So, and that's the final result. So we ported the shader correctly. More or less, that specific shader, I think it is ported correctly. And if we try to use the different Wang tile, right, if we try to use the different Wang tile, right, so that's the result. So it has a different thing. So it's a binary counting, right? So it's a binary counting. So, and where is that? Like this, and if we have like a 1, 1, 1, as far as I know, 1, 1, 1 is like 15. I think it is 15, right? And then if I do 1, 1, 1 in here, right? It should also produce the thing like that. Okay, cool. So that's pretty pow, not gonna lie. Now, what we want to be able to do, so we're generating the a single tile, only a single tile, but I want to be able to generate the whole atlas, if you know what I'm talking about, the whole atlas as well. So we call it tile set in the Pascal code base, but I want to call it atlas because I think it makes more sense. So let's go. So because of that, I want to remove that. Okay, so we're gonna have atlas. Atlas width, and we also need to distinguish the measure units, right? Again, so pixels versus cells, or maybe versus tiles as well, right? So here I'm gonna go ahead and just query replace tile width with tile width px, right? And tile height, right, with tile height px. Right, and what I want to have in here is atlas width in tiles, right, so we're going to have 4 of them, and atlas height in tiles, also 4 of them. Then we're going to have atlas width in pixels, and this one is going to be, well, I mean, yeah, so tile width, atlas width in tiles, atlas height in tiles. There we go. So we have an atlas width and height in tiles, and then in pixels. And why we need that in pixels? Because we're going to be, you know, allocating memory and saving all of that, and so on and so forth. All right. So, shit. I wish there was an easy way to like bake this kind of things, but. Maybe the shaders should have some sort of a context. I don't know. Maybe they shouldn't. Or maybe the shader should just accept BLTR. Let's just make the shader accept BLTR. Hello, Sinego Pombo. I hope I pronounce your nickname correctly. I don't know how to pronounce it. So let's actually make it accept BLTR. I think that will be kind of useful, right? So this thing also accept BLTR, and yep. So let's go to the compilation errors. So that also means when you're generating an image, you have to accept BLTR that you want to put in there. Right, there we go. And here, what I'm going to be doing is 15 and also Wang. There we go. So now I don't need this Wang because I'm not going to have any other things, right? Because we're specifically generating Wang tiles, right? So nothing else. All right, so that's pretty cool. Now let's allocate some memory for the atlas. Right, let's allocate some memory for the atlas. It's going to be RGBA32 atlas, atlas width in pixels, atlas height in pixels. There we go. And here is an interesting thing. Since we have a stride, right, we can use generate image. We can generate image right inside of the atlas. You see what I'm talking about? Right, so imagine that you have an atlas with several slots for the tiles, right? So this is the first tile, right? Then I suppose I can copy paste this thing and then say that this is going to be the second tile. So then we're gonna have a third tile, right? Then we're gonna be having a fourth one, then fifth one, sixth one, and so on and so forth. So this is the atlas that packs all of the wank tiles. Since we discovered, right, the concept of stride and our generate tile function, generate image function accepts the beginning of the pixels width, height, and stride, we can now tell this function, okay, generate the tile in here quite easily, providing only width and height of the tile and the stride. So in this specific case, if I want to generate this tile, what do I have to do? I have to give it the pointer to here. Right, so the pixels will point to here. Then width is going to be 4, the height is going to be 4, and the stride is going to be 12. And that way this function will basically generate this thing, then skip 12 basically characters, right? So this is how much it will skip, will it? Yeah, it will skip 12 starting from here, so it will skip this entire thing, generate the next thing, then skip yet again this entire thing, and so on and so forth. So we can now basically generate through each individual tile, and providing only width, height, and stride, we can say, okay, generate it into this slot of memory. So then that makes it actually super cool and super easy actually to work with. Yeah. That's actually cool. I really like that. So, and maybe we can have more of these things in here. So that's basically our atlas. I really like this idea of the stride. So once it clicked in my head, it's just like, yeah, that makes so much sense. Where exactly is the logic for neighboring wank tiles handled, by the way? Nowhere, because we didn't implement it yet. Sorry, no free food. I'm not a god coder yet. Or maybe ever gonna be. We're gonna implement it soon, don't worry about it. So I'm just porting my old Pascal code to C. And yeah, we'll see. Anyways, so let me see. How are we going to be approaching all that? So I think I want to, since we have to now provide BLTR, right? I'm going to rename this thing to generate tile rather than generate image, right? So it's going to be tile 32 because you are specifically providing the mask of the tile, right? So this is the mask of the tile, and here what we can do now, I can iterate through the rows of the atlas. So I think it's going to be something like this: 0 less than atlas atlas width. Is it going to be atlas width in tile, height in tiles? I think it has to be height in tiles. Right, for size tx 0x less than atlas width in tiles plus x, right? And there we go. Okay, so So it's more of a, I would actually call it a row and column, right? Row and column. So BLTR in that specific case is going to be essentially row multiplied by the amount of columns plus the column. That is basically the index, right? This is basically the index. We can go the other way around, actually. We can be generating BLTRs from 0 to 16, and we're gonna be extracting the rows from BLTR. You can actually do the like however you want, but I think maybe this loop that iterates through all of the BLTRs and extracts rows and columns from it is going to be shorter and simpler, I think. So, and row is going to be what? Specific row is basically BLTR divided by the size of the amount of columns, right? And the column is mod of this thing, right? So, okay, so this versus this. These are equivalent, by the way. They are equivalent, but I think this one is a little bit easier to read. It's just shorter, yeah. Think about it. Well, I mean, n is different in that case. I would say that one is O of n, the second one is O of m squared, right? So the n's are different here. Anyway, you know that, you're joking, I'm sorry. All right, so what we're going to be doing here, we need to generate the tile, right? We want to generate the tile. So where do we start the pixels? Where do we start the pixels? Oh boy. So essentially, we want to start at, I suppose, y, which is a row multiplied by tile width in pixels, and x is a column multiplied by tile width in pixels. And I think we could have even, you know, squashed all of that into something like this, because we don't really need that intermediate row and column. Right, we don't need that intermediate shit. So now the pixels we're doing here is going to be atlas y multiplied by the atlas width in pixels plus x. This is where you start the thing. The size, the width, is going to be tile width in pixels, the height is the tile height in pixels, and the stride is actually very interesting. It's essentially atlas width in pixels. So this is where width of the image and stride starts to deviate. You see? Now the width it's tile, but the stride is going to be the whole thing, so you actually wrap around correctly, right? And then we provide the BLTR, and the shader is going to be the Wang shader. So that's actually pretty cool. Stride makes perfect sense. It just does. So, and in here we probably need to change the width and height and whatnot. So this is going to be atlas width, atlas height, and we're just saving the atlas, not the specific tile. So it just makes it easier to say, okay, generate it into that piece of memory, and you have enough information to just do everything. So this one is BLTR, okay, and this is scary, something is wrong, okay. So something went horribly wrong, and I don't know exactly what. So it started to hang for some reason, and I don't know what exactly is going on. So it compiled relatively fast, but now it hangs, which means that we have an infinite loop somewhere, but the question is where. Don't really understand, because why would it hang anywhere? If you know what I'm talking about. So does it hang somewhere here? Right, so if I try to run it like this, right, Oh yeah, it does. Oh no, it doesn't. Okay. So it hangs somewhere in generate tile. And again, where would it hang there? Or am I crazy? Am I going crazy? I feel like I'm going crazy actually. Because there's literally nothing anywhere in here that would hang. So I think maybe it's just slow. Right, you know? What if this entire process is just slow? It could be. Okay, so let's actually indicate what's the current tile we're rendering. An anonymous user is gifting 5 tier 1 subs to the Soaring community. Thank you so much for gifting the tier 1 subs and everyone who got the subs. Welcome to the community. It will go for some time, so I think we're gonna skip that. Alright, thank you for all of the subs. Let's continue. So, what is going on in here? Yeah, so I wanted to have an indication of what's the current tile we are generating. Generating gut seed. It's gonna be T. And yeah, there we go. I'm gonna be generating gut seed. So maybe I'm gonna also do something like this. Did you start recording again? Yes. I mean, I'm always recording. It's just like I make markers in a special program to do the cuts, and I do the cuts automatically with FFmpeg. Right. It is always recording. Nothing is really lost. So, okay. So it is actually slow. That was the reason. And now, oh, okay. And then it needs to take some time to record everything, and there we go. There we go, it generated everything. Look at that. That's actually pretty cool. So, and that's really cool that it just generates into specific slot. Right, so it's gonna be black. Output PNG. So does it? Yeah, so the entire thing is too big, I suppose. Yeah. There we go. Here's the thing. Is always recording and makes marks send data, but yeah. So I suppose this is because the size of the tile is so huge, right? The size of the tile. So maybe if we make like 64, it's going to be a little bit faster. Right. Yeah, it's way faster now. So here's the output, and this is a very small thingy. Yep. So 64. There we go. So now we have that. Do we need to actually port anything else? We ported that, we ported this and that. And I guess that is pretty much it. That is pretty much it. Your porn folder size went from 2.2 and to 9 gigabytes. 9.2 to 9 gigabytes. Well, I mean, the porn is consumable, right? So the more I stream, the less porn I have. It is what it is, and it isn't what it isn't. So, okay. We have everything I wanted. Let me see if we need to copy some things. More Wang ideas. Okay, so this is that. Any other to-dos? Try to link with STB. We already solved that, by the way. And generate the random Wang tile grid. Okay, so that's the last piece of to-do that I would like to have. So generate the random Wang tile grid. Okay, so that's pretty powerful. I suppose we did it. We generated the whole thing. So now we should be able to get rid of the old Pascal code, hopefully. Right, I'm removing the Pascal code. There we go. Officially. Now officially. We don't need STB image. STB image needed for reading, but we only need to write things. Right, so we're not going to include that. So for writing is actually a little bit simpler. So here's the tile set, and so on and so forth. Yep. We can also try to change some of the colors just to see if it also works fine. Right. So boom. So now here's a different color. So we're using complementary colors. So let me increase the size of the tile. 64. Maybe 256 should be fine. Generating gut seat. Okay. Yeah, looks a little better. So what other complementary colors we have? That's cool. So, and by the way, we never actually compiled with all of the optimizations. Let's actually enable O3 and see how fast it will get. It's pretty fast. What about Clang? I heard Clang performs more optimizations. It's pretty fast. There we go. So let's go back to... I kind of like yellow and blue. I think it looks nice. Oh, fast. Is it going to be that much different than O3? I'm not sure. It's pretty fast. Sorry. Got you guys got seats. Okay. All right. So Pascal to C. Right. We'll probably need to use a different build system now. Approximately the same as O3. Yeah, probably. It's approximately the same. So are we gonna use no build or are we gonna use something else? Let's use no build. I don't know. I'm a little bit tired already. So let's go. No build. Let me grab this thing. KSH script. Who uses KSH in 2021? Does anyone use that? I don't know. All right. I think KSH is used like in FreeBSD, right? Isn't it? Fish script. That's a nice idea. Build implementation. Agree. And we're gonna do go rebuild yourself. argc argv. And what we're gonna do in here, I think I'm gonna create the usual cc thingy, right, which grabs the result from the environment variable. Get env. Oh, I just remembered that I have a very cool idea for a project after we're done with Wang tiles. It's gonna be, holy shit, bruh. It's gonna be so cool. I mean, for some people, like for nerds like me, not for everyone. So I want to still have a schedule application, like, you know, schedule website, because it's the entire idea of this having schedule that updates automatically. It's kind of dead, but I have an idea on how to revive it. And the schedule is going to be again written in C. I know I tried to do a skedoodle in C, and it's kind of difficult, it's kind of janky and stuff like that, but I have a cool idea that writing in C could make it viable. That's the only thing I'm gonna say. And it's gonna be so freaking nerdy. It's just beautiful. It's gonna be perfect for this channel. It's just like, holy shit. I'm not gonna say anything, I'm not gonna spoil anything, but yeah. So it's gonna be schedule that, you know, can be integrated with bots and stuff like that. You can use it, and it's gonna be written in C, and it's gonna be viable in C, I think. I think it's gonna be viable in C. Yes. Okay, so if this thing, right, results, hopefully, I don't know, like I'm not gonna, you know, try to predict the future, maybe it's gonna fail as well. If we have a result, we return result, otherwise we're gonna be returning C. Okay, so I'm gonna do cmd, cc, c flags, o, wang, and we're also gonna link with libs, I presume, and the input is gonna be maybe main.c. So that should be it. That should be it. Of course, yeah. We'll need to have a run subcommand and some other shite. Let's define C flags. So we need all of the warnings that we can. Some extra warnings. This standard is gonna be C11. We're gonna be pedantic about it. Pedantic. Then we're gonna enable the debug information. And I also want to enable enum switch, even though I don't plan to use too many enums in here, but I'm gonna do enum switch anyway. I don't remember, is it switch enum or enum switch? 9011. Okay. I'm not sure if computers even existed back then. Right. So when Turing, well, I mean, Turing posted his paper in like 1940 or something. Turing paper. Turing paper on halting problem. When was it posted? 1936. Right. So this is where he introduced the Turing machine and stuff like that, and sort of like things took off, I think. I'm not sure. Right, so yeah. In 1911, we didn't even know if halting problem is decidable. So just saying. Halting problem is more handled. Yeah, it is actually. It's pretty old. How does that make you feel? It's a good question. Why you're asking me that? I don't know. You know, okay, so here's the interesting thing to think about. We have a lot of technologies, we still use a lot of technologies from 1970, right? So a lot of shit came from 1970. This is actually pretty monumental like year in the computing history. Like Unix was formed around like this year, C and so on and so forth. And we still use a lot of concepts and a lot of things from 1970. This shit was more than half of a century ago. So 30 years to 2021, more than half of a century. In programming, in computing, we haven't advanced in more than half of a century. Just think about it. X. Turing is the cause of internet porn. Internet porn. Is it somehow different from just porn? So why do we need to have a separate category? I thought the internet is just a medium, right? So the medium doesn't make the genre that different, I think. I don't know. Okay, so it's cheaper to build on the old than create. I don't think so. The salaries of programmers keep growing, so I think it becomes more and more expensive. And the reason why they're growing is precisely because the complexity is so huge and because building new things becomes more expensive. Right? If we ditched a lot of shit underneath, maybe it will become cheaper. So I actually disagree with that statement. It's just like, it's really expensive and it feels like some sort of like a financial bubble actually. So yeah. So GCC no build, let's see. Okay, so what do we have in here? So libs, did I actually introduce? Yeah, we need to introduce libs. Okay. Alright, so we have a bootstrap no build. And did it work? Oh yes, it's a switch enum. I think it's a switch enum. Yeah, that's what it is. There we go. So now we have a build system. Right, in that build system, if argc is greater than 1, right? and then if strcmp argv1 run equals 0. On top of that, we're gonna just try to run the wang thingy. Right, otherwise we're gonna panic. Okay. So there is a pretty cool feature in Emacs that John Blow himself called useless at some point in history. It's a swap to nearby words. So basically you put a cursor between the words and you press Alt-T and it swaps it around. So, and what's interesting is that the boundary of a word in Emacs is decided not only by spaces, but also by special characters. It actually depends on the mode. In different mode, Emacs uses different tokenizations and it has different word boundaries. So, for example, it will work with dashes as well. So, and if I have something like switch in num, it's super easy for me to, because for Emacs, it is two separate words because dash determines the word boundary. For that specific mode, it depends on the mode. So, yep. Does that answer your question? Unfortunately, I have to do a special trick. If I try to do it like this, it will include W. So what I had to do, you probably saw it, I had to put space in here first, and then remove the space. So that's what I had to do. So I just did it too fast. You probably didn't notice that I had to do that I did that, because like the boundaries are not particularly correct in this case. All right. So the panic. Oh, you did notice it. Okay, that's cool. Unknown subcommand s and it's gonna be argv1 Zulu. Okay, so of course we have a problem in here. Boom. Okay, and then I can just run this entire thing and generated cutscene. Cracks me every time. Well, I mean, I have a cooler idea actually. So we can use this thing. Like this. Oh yeah, and you'll have to multiply it by one palette, of course. Well, what I mean, we don't really have to do it like that. We can put 0 in here, I think. Yeah, there we go. So that's cool. All right. Generating gas. Holy shit. Oh, okay, I'm sorry, I forgot. We have to put printf generated dream seeds. First in CD. Okay. So we also need to ignore some of the shit, right? So it's gonna be Wang as well, PNG. Not really PNG, I'm not sure. Well, I mean, we're using PNG in here, so it's probably I don't know. Add first names, nah, yeah. No build old. Alright, so here's the output. I suppose I'm gonna git ignore specifically output PNG, at least for now. Rewrite Pascal code in C. And what we're gonna have in here is also readme. So I'm gonna quickly change this to RGB Wang BLTR. Like, I might as well actually call it BLTR, then UVF. Okay. As a bit mask, blah blah blah. Quick start. The project is using no build system. HTTPS github.com setting no build. So cco no build.c, and here we're gonna have UV maybe. Yeah, probably. Sure. Why not? No build run, and then the output pinger. All right. Update readme. And let's push that right into the repo. Cool. So let's make a pull request. And well. So this one is C. Remove mentioning Pascal. All right, and also let's remove that thing from here. There we go. Finally, we ported this thing from Pascal to C. Isn't that amazing? I don't have a CI, I just realized that. Pascal to C. Let's create a pull request. That's a lot of changes, but this is primarily STB library. Yeah. So let's just merge pull request. Rust port, yeah, we're gonna keep writing the same thing in different languages over and over again. Infinite content, by the way. Infinite content. Okay, so I guess I want to move on and finally write the actual grid generator. I'm not sure if we're gonna have enough time to do so, but maybe, I don't know. Wet dreams of the chat comes true. Probably. I don't know. I could probably do a Rust stream at some point, yet again, when I'm in the mood of dealing with Rust people. But right now I'm not, so I'm not gonna do a Rust stream. It would be really interesting to explore the grid generation, but unfortunately, I'm super tired right now. So maybe next time. So what's the day today? Today is a Sunday. I think I'm not gonna push myself too much. So I think that's gonna be it. All right, so that's it for today, boys and girls. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all next time. I really want to finally finish the actual Wang tile grid generation with the constraints and stuff like that. And yeah, probably we're gonna do that. Maybe at some point we're gonna also port that to OpenGL. It would be kind of cool to actually like do this kind of things in the shader, because you can pass BLTR via the vertex buffer or something. You can generate only BLTRs, the grid of BLTRs. You can push it into the graphics card, and the graphics card is going to do the rest of the work of generating specific pixels and whatnot. That'll be actually kind of cool. If you know what I'm talking about, that'll be kind of pogue. I'm not gonna lie. But all of that next time, because I'm really tired right now. Thanks everyone for all of the subs and stuff like that. Really appreciate it. Love you all.